Hi class, and welcome to our video lesson on the empirical rule. It's also called the 68, 95, 99.7 rule. Now this rule only applies to normal data, and normal data means that it is symmetrical about the mean. We get a bell-shaped curve that is completely symmetrical. And when you see these bell-shaped curves, class, it's when you have a bunch of data entries. Let's just take, for example, the heights of adults. And if we just take like 10 people, we would get probably quite a spread. We would get maybe some taller people way over here, and maybe we'd get some shorter people way over here. But if I would say of those 10, most of them would be kind of around the average. So as we get more and more data observations, now let's say we get 20. Now again, there's more people around the mean. There's going to be some taller ones, and there's going to be some shorter ones. If we get 1,000 people, well, most of them are going to be in right around the mean, average heights. There'll be a couple that are pretty tall. There'll be a couple that are pretty short. And as we keep on getting more and more data observations, more and more people are around the mean. Let's take 10,000 people. You're going to get in 10,000 people some that are extremely tall, 6'9", 6'10", 7-footers. And you're going to get some extremely short people, but not very many. Most people are going to be right around the average. And so we get this normal bell-shaped curve. And that always happens when you get a lot of people, a lot of data entries. And statisticians have found that whenever you get a lot of data entries, between -1 and a +1 standard deviations away from the mean, that's where 68% of the data are going to lie. So in this red space right here is over half of the data. 68% are right around the mean. 0 is the mean right here, class. If you want to put X bar right here, 0 is the mean, and then 1 standard deviation away from the mean, 2 standard deviations, 3 standard deviations from the mean, and a -1, -2, -3. So now the 95 comes in because almost all of the data, 95%, becomes a -2 and a +2 standard deviations away from the mean. And then 3 standard deviations is 99.7% of the data. There are few data entries that are greater than 3 standard deviations away from the mean or less than 3 standard deviations away from the mean. So that's the 68, 95, 99.7 rule. Let's learn a little bit more about this. Here we have the distribution of heights of young women ages 18 to 24. It's approximately normal. This N right here means it's normal, so it's a symmetrical bell-shaped curve. This 64.5, that's the mean, and the 2.5 is the standard deviation. Okay, so if you ever see it written in that notation, know that the first number is the mean, the second number is the standard deviation. So we're going to label the bell curve below, and then we're going to label the points that are 1, 2, and 3 standard deviations away from the mean. So our mean is 64.5, so that's at 0. Now every standard deviation is 2.5, so now this is going to be 67 is 1 standard deviation from the mean. 2 is going to be 69.5, and 3 is going to be 72. We just add 2.5, add 2.5, add 2.5. Subtract 2.5 to get 1 left of the mean. So a -1 standard deviation would be at 62. And then at 59.5 when you subtract 2.5, and then at 57. So the average woman, ages 18 to 24, is 64.5. What are we talking about? Inches or centimeters? Inches. And then we have 67 inches is 1 standard deviation away. 69.5 inches is 2 standard deviations, so on and so forth. So now we can answer these questions. What percent of young women have heights that are greater than 67 inches? So we want to know what percent is this. Okay? So we know it's less than 50% because 0 to the end is 50% of the data. Half, the mean is half of the data. So it's got to be less than half. What we could do here, class, is we could take half of the data, so 50% of the data, and subtract this much right here. and from 0 to 1 is half of 68. A bell-shaped curve is symmetrical, so if negative 1 to positive 1 is 68% of the data, then from 0 to 1 is half of 68. So to show your work, 50% minus half of 68, that's going to be 50% minus the 34%. So the answer is 16% of the data. 16% of women are taller than 67 inches. Let's answer the next one. What percent of young women have heights between 62 and 72? So between 62 and 72, here is 62 and here is 72. So I want all of this data right in here. Okay? So from 0 to negative 1, once again, is half of 68%. Between negative 1 and positive 1 is 68, so between 0 and negative 1 is half of 68. So half of 68, and I also want this, which is half of the 99.7. From 0 to 3 is half of 99.7. So plus 1 half of 99.7. So then you would get another 34%. Plus half 99.7 is 49.85. So our answer to this one, when you add up those two, 83.85%. A lot of the data is between a negative 1 standard deviation to the left and a positive 3 to the right. Okay, last one, talking about these women's heights. If we have less than 59.5. What percent of women are less than 59.5? So here's 59.5, so we want to get this. Well, again, from here to here is half of the data. So that's 50%, and we want to subtract this much. If we subtract this, then we'll get less than 59.5. So if we subtract half of 95, because from here to here is half of 95% of the data. If we subtract that, then we'll just get the heights of women that are less than 59.5 inches. So 50 minus half of 95 is 50 minus 47.5. And when you subtract those two, 2.5%. Okay, there's our first example problem. Here comes our next example problem. The length of pig pregnancies isn't always the same. In pigs, the length of pregnancies varies according to a normal distribution. So once again, the data is normal. The mean is 114, so at 0 standard deviations, there's the mean. It's at 114. And then the standard deviation is 5 days. So here is 119. Here is 124. Here's 129. Here is 109 days. Here is 104 days. And this one is 99 days. So most pigs have their piglets at about 114 days. But there's several, there's quite a few pigs that have their piglets 2 days before the due date or 2 days after the due date. Just like people, some people they go early, some women they go late. It's very it's not ordinary though for a pig to have their piglet at around like 99 days. That's really early. That's a premature pig. Same thing here at 129. That pig has been, pregnant for way too many days. That's very abnormal. Okay, so that's kind of what we're looking at here with this normal data. What range covers the middle 95% of pig pregnancies? 95% is between a negative 2 and a positive 2 standard deviations from the mean. So between 104 to 124 days, 95% of pigs are pregnant between that range, 104 days to 124. What percent of pig pregnancies are longer than 114? Well, 114, that is our mean. And in symmetrical data, the mean is the halfway point. So 50% of pig pregnancies are longer than 114, 50% are shorter than 114. What percent of pig pregnancies are shorter than 109? So here's 109. I want this percent. So it's going to be less than 50%. It's less than a negative 1 standard deviation from the mean. So I'm going to take 50% and I'm going to subtract this much. Because here's half of the data and I don't want the red. All I want is the green. So I'm going to subtract half of 68. This right here is 68% of the data, so if I subtract half of 68, I'll just get the range that's less than 109. So 50 minus 34, the answer to that one is 16%. What is the median length of pig pregnancies? Well, class, in symmetrical data, if the mean is 114, symmetrical data, the mean and the median are at the exact same spot. So 114 days is the median as well. So now for the rest of the notes, class, it's just kind of practice on doing those standard deviations away from the mean and what percent they are and stuff like that. Why don't you guys pause the video, try the 6 on your own now, and then check your answers with me. So here is letter A here, 3A. What percent will fall below 0? There is 50% of the data. That is the mean, so 50% fall below. What percent will fall below 1 standard deviation? Here's 1 standard deviation. So more than 50%, it's 50% plus this much, which is half of 68. So 50 plus half of 68, there's 84%. What percent fall below a negative 2 standard deviations? So here's a negative 2. I want to find this range. It's going to be significantly less than 50%. It's 50% of the data minus half of 95. Up to negative 2 is half of 95. So 50 minus half of 95. That would be sorry about that, everybody. I made a very big mistake. What percent of data will fall above a negative 2? So now above a negative 2 is significantly greater than 50% of the data. So here's negative 2. I want all of this. So that is going to be 50% plus this half of 95. 50% plus half of 95, that's 97.5% of the data. Sorry about that. Here's letter D. What percent of the data will fall below 3 standard deviations? Once again, almost all of the data falls below 3. Just a very little bit is above 3. So it's going to be all 50 of this percent plus this much percent, which is half of 99.7. So almost all of the data, 99.85% of the data falls below 3 standard deviations. Very uncommon. What percent of data will fall below a negative 1? So here's where negative 1 is. I want all the data below, so that's to the left of. So it's 50% of the data. Subtract this much again, which is half of 68. 50 minus half of 68 is 16%. What percent of the data will fall above 2 standard deviations? So here's 2 standard deviations. What percent fall above it? Less than half. It's going to be 50% minus half of 95. 50 minus half of 95, that is 2.5%. And last one of the day, what percent of data will fall below 1 standard deviation? Here's 1 standard deviation from the mean. So what data falls below it? It's going to be 50% plus half of 68. This much is half of 68. So the 50% plus half of 68. So that would be another 84%. All right, let me know if you need any more practice with that or any more help when you get to class tomorrow. Hopefully that made sense. That's called the empirical rule, 68, 95, 99.7.